right, guys, so we're on to properties of matter. Remember, an element is the basic building block of all matter. It cannot be broken down into a simpler form. There's 118 represented on the periodic table. We use symbols to represent them. Example C would be carbon. Remember, an element is, if you take something away from the element, if you take the atom away from the element, it becomes something else. So like carbon has 6 atoms. Take one away, now it has 5, it becomes boron. Okay, you cannot break it down. Atoms is the smallest part of an element that has the properties of that element. They make up all matter. All atoms have mass and occupy space. Oxygen is in the room right now. If there wasn't oxygen, then you couldn't breathe, but something else would have to be there. Or it'd be like a vacuum seal when they pull out all the air. So oxygen has a mass. It weighs something. It's taking up space. Atoms of the same element have the same properties. If it's a carbon atom, it's a carbon atom whether there's a lot or a little. A compound is 2 or more atoms of elements chemically combined, like water is 2 hydrogen atoms, 1 oxygen atom. Salt is sodium chloride, and then sugar is carbon, hydrogen, and oxygen. The little numbers represent how many of each there needs to be. When combined in a compound, elements change properties. Example, NaCl is table salt, but separately, Na is a metal and Cl is a gas. So you have a metal and a gas that combine together and make something that you eat all the time. All substances have properties, some physical and some chemical. Use the information in the following slides to complete the chart on page 8. I need you to do this, okay? So, mass. It is a measure of the amount of matter within a substance. Remember all that alliteration. Mass, matter, amount, okay? Within a substance. Balances are used to measure this. It does change if you change the amount of substance. Okay, it asks you the question. I'm telling you the answer. It does change. If I have a cup of water and I have a gallon of water, those don't have the same mass. There's more matter in the gallon than in the cup, and it's going to weigh more. Weight is the measure of force of gravity on a substance. Remember, you are the same no matter what. But if you got to go to the moon, you are going to weigh less than what you do now because there's less gravity on the moon. Spring scale, the little thing like that it pulls down. It's kind of like what they use at the grocery stores to, if you want to see how many pounds of bananas you have, you put it on there. Weight does change based on the amount. Volume, the amount of substance that fills a certain area. Beakers may be used to measure. A golf ball and a ping pong ball. They're both about the same size, yet a golf ball has more matter in it. It is denser. There's more stuff tightly packed, and that's going to make it have a bigger volume than a ping pong ball that doesn't have a lot of matter in it. Volume does change based on the amount. Melting point. It's the temperature at which a solid melts to a liquid. A pure substance. It's made strictly of one element. It has a known melting point. Gold is an example. Many metals are common examples. We know what temperature to get a metal to melt it. We know water is 32 degrees Fahrenheit for it to start melting. 212 degrees for it to start boiling. So we know that of water. We also know it of different metals as well. Boiling point, it's when the liquid boils and it goes to a gas because the molecules are moving everywhere and they're very excited. They keep going. It remains constant as long as the water is boiling. If you shut it off, then it's going to start losing some of its energy, losing some of the heat because it's trying to get to equilibrium, and it won't be boiling. Water boils at 100 degrees. Density is mass to volume ratio. Mass, how much matter is in it, by how much space does it take up, tells you the density. How tightly packed are the molecules? Okay, remember the example with the rice? I can stick a pencil in the rice and it will come right out, but because the other bottle is more tightly packed, I had the rice all the way up to the lid. When I stuck the pencil in there, it didn't come out because there was no room for it to go. It remains constant regardless of the state. Whether you have that cup of water or that gallon of water, water is made of water. So it's going to be easy enough, the same way to move through it. Lead is a dense metal. Lead is tightly packed. It's, sound can travel very quickly through lead. Solubility is the amount of solute that can be dissolved and the amount of solvent. Okay. What you're putting in there. So say you're putting sugar or salt into water and you're stirring it up. The solvent is the thing doing the dissolving. The solute is the thing that gets dissolved. So, you have to salute the sergeant and salute and solvent kind of sounds like sergeant. It's the way I remember it, y'all. Use the following information to complete the chart diagram on page 9. So, page 9 has some information. You're going to be filling this out. And then if you need more room, there's a note section at the bottom. Each phase change is caused by a change in temperature. Increasing temperature causes the molecules in a substance to move faster. So you notice they're in a solid, liquid, they start to move out. Some are still touching, and a gas, they're all spread out. So solids, they're rigid. They have a definite volume and shape. The atoms and molecules are packed closely together. Atoms cannot be moved closer together, but they are constantly vibrating, and it cannot be seen on a large scale, but we do know that it's happening. Liquids have a definite volume, but can change shape by flowing. You take a cup of water, you pour it on the ground. You don't have a cup just sitting there of water. Okay, you have a puddle. Atoms or molecules are touching, but they can move around. They're just flowing. The density is similar to that of solids, and they can take the shape of the container. Okay, you guys know that see how it's really small? I try to fit it in there. That's kind of what I'm looking for you to do. Gases have no definite volume or shape. They can expand indefinitely or spread out indefinitely. They have enough energy to overcome forces, meaning they rise. So everything, gravity says that we should fall down, but because they have so much energy, they go up into the air and they keep going. Water vapor. Water vapor doesn't just stay here on the ground. It goes up to make a cloud. They have a low density because the molecules are so spread out. Like I can't have a pencil and drop it in. The air's not going to hold a pencil, y'all. And they can take the shape of a container if confined to a space. Balloons. Balloons have a specific shape. They take that shape when the gas is pumped into it. So these are just some cool pictures. You can see these milk interactions. So why do you think this happens? Like notice, like this to me looks like Saturn. You get like a little spaceship. Like they're all different. Why do we think that's happening? Comment. Let me know. And we'll be picking up there. Have a great one.